Alright, so what I've got on Google Classroom here, I've got it broken down into the first thing I posted. Let me scroll here. Okay, there we go. The first thing you'll find is convex and concave polygons. That is a video. When you click on here, you can see that my internet is running my hotspot's running very slow. This is a video that I put on. It's 3 minutes long to explain to you guys the difference between convex and concave polygons. Okay, so that's the first thing I put on there for you, and that's to help you with number 1 on the worksheet. And then I divided the worksheet into 4 parts, 1, 2, 3, and 4, and I put them on here. Okay, this is number 1, number 2, number 3, and then number 4. Okay, all right, so let's look at number 1 first. So number 1, you're supposed to graph A, B, C, D, E, F, G, H with these coordinates. Okay, so there you go. And when you graph it, you obviously have a polygon there. And then on B it says, remember that a diagonal is a segment connecting blah, 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 blah. Okay, convex and concave. If it's convex, you won't have a cave to go hide in. If it's concave, you have a cave to go hide in. So when you look at this, is there anywhere that you see an indented area that would be like a cave or a Pac-Man where you can go inside and hide? So is there any indentation in it? Okay, so is there a cave where you can go hide in? And if the answer is no, then it's convex. If there's a cave or an indentation, then it's concave. All right, so that's what you have to look at and figure out. So go look at your video after you've looked at this and say, okay, now after you watch the video, you should be able to tell if it's convex or concave. Okay, all right. Then it says on C, to find vertical or horizontal side lengths, just count the spaces moved. Find the following lengths. Okay, so all I'm going to do is count the lengths. And I laid down my pen. Let me grab it real quick. Okay, so if I want to find the spaces between B and C, I'm just going to count. This is 1 space, 2 spaces, 3 spaces. Okay. For the vertical, you do the same between D and E. That's 1 space right there, 2 spaces right there, 3 spaces right there. Okay, so that's what you do for your vertical and your horizontal. Okay, all right. Now, for your slant, to find the lengths of the ones that run diagonally, all right, that would be this one, this one, this one, and this one. Then you're going to use our all-time favorite distance formula. Okay, so let me get on the back here where I have this written down, and wait a minute. You know, when you have everything together and then you start filming. Okay, there you go. There you go. All right, so part D. If I want to find the distance between C and D, C gives me the 0.72, D is 9.4. So I'm going to call this 0.1. I'm going to call this 0.2. All right, so we're going to do the square root. Y'all, this is terrible, but it is what it is. Okay, so x2 is 9. X1 is 7 squared plus My hand's in the way, of course. Y2 is 4. Y1 is 2 squared. Alright. Alright, so 9 minus 7 is 2 squared plus 4 minus 2 is 2 squared. So this becomes the square root of 4 plus 4, which is the square root of 8, which is, alright, let me get the old calculator here. Let me clear all this. Square root 8, and that's going to give me 2.83 if I round it, okay? Alright, so that is CD, which is where? Here. This one's 2.83. Okay, and I'm going to have to calculate EF and GH. Now AB I've already got. He gave us AB. Now I know that CD is also 2.83. I'm going to check EF and GH, see if they're all the same. And so the question was just basically, are they all the same? And then why? Okay, so if they're all the same, why are they all the same? So, you know, I'm looking at, okay, AB is this one. And look at the triangle you got here. A, B. Look at the sides. This is 2. This is 1, 2. And then I just did CD. The triangle in this one is also 2 and 2. Your X and Y changes are the same on these two. Are they going to be the same on these two? So your X and Y changes, okay, have to factor into this, okay? So that's some of what your thinking needs to be, all right? Now, E is, remember that a polygon with equal side lengths is called equilateral. Is this one equilateral? All right, well, look here. What did we find the lengths to be here? We counted them. What are the lengths here? Are they the same? Yes or no? If they're the same, then it's equilateral. If they're different, then it's not. Okay? Now, if a polygon has all the angles the same, it's called equiangular. So is this one equiangular? Now look. Look at this angle right here. All right? This right here, this box right here represents a 90-degree angle. Okay? And then it drops down not quite 45 degrees. But I want you to look at the triangles in all the corners when you get done and recognize that all of these triangles, are they all identical? You can tell by this right here, right? Okay? But this is a 90-degree angle here. This is a 90-degree angle here. This is going to be a 90-degree angle sitting here. This is going to be a 90-degree angle here. But if these triangles sitting in all of these spots are the same, next to them, what does this tell you about the angles next, the angles sitting in the corners, you know? If all of the triangles are identical sitting next to those 90-degree angles, then the angles should be identical, okay? All right? Because when you have a triangle that has a 90-degree angle, and this leg is a 2, and this leg is a 2, we already learned that if the sides are the same, then the angles opposite those sides are the same. All right? Because that's isosceles, okay? So we know these two angles are the same. So keep that in mind when you're looking back up here at what you've got. So we know this angle, sorry, I'm having to draw so tight, and this angle are equal. Okay, so this is a 90-degree angle sitting here, and this is a 90-degree angle sitting here. So we know that these two angles at least are equal. Are all of the others the same? All right, think your way through it, okay? Think your way through it. Is that all identical? Then it would be equiangular. Now, if a polygon is both equiangular and equilateral, we call it regular. Now remember, is it equiangular? Did you figure that out? Yes or no? Is it equilateral? Was it? Was it equilateral? Okay. Then we call it regular. It has to be both to be regular. All right. Okay. All right. I think that's all I had on number 1. So I'm going to stop this video here. I'm going to do a separate video for the next part.